Hi everyone, how are you? How you doing? Uh, Welcome back to our classes. Today we will finish what we start, or we're gonna try to finish some of these topics in physics. Yesterday we start with the electric force. We're gonna try to get electric work and electric potential energy. And as always, don't forget to like and subscribe. Let us see what we have. I need to connect yesterday class with today class. What I mean by this, look guys, hi. How are you? How you doing? I wish you're doing good, you and your family. Yesterday we stopped at this point, at this problem. Just for the kids or any student. If you missed yesterday class, the last thing we will talk about, we have three charges, Q1, Q2, Q3, Q2, 2 microcoulomb, Q3, 3 microcoulomb, Q1 is negative here. You see, this guy is negative, and he wants me to find the force on Q1, the force on Q1. What I did, Q1 is negative and this positive, but give me attractive force. Good. This guy, then the same thing here. Then look here, you have to notice the charge will move. The charge, he wants you or she wants you to find the force. Then Q1, Q2, this number one. Then after that, we apply the formula for the force. And remember this formula, how we get this formula? And when I told you there is a charge plus Q, this charge has, remember how we get this formula? This charge has, electric field line goes out, because it's positive, it's negative, it's N. And this charge has electric field, and this charge has electric field anywhere in this field. Anywhere in this field. Now, anywhere in this field. This charge then has what? Electric field. Now, imagine this your electric field. If you have here, this guy has distance d from. Now, if anyone in the world try to come close to this charge, we're gonna get affected by a force, and the force F equal what? F equal Q times the E. And you know from before that E is KQ. Just back to my old videos, D, Q, KQ over D, K, Q over D. And remember, this is Q, and this another, if Q2, and this Q1, right? This is Q2, and this Q2, and this Q1, then K, Q1, Q2, K, Q1, Q2 over D, and K the constant. That all what we did yesterday, and that all. Then after that we calculate the force between 2 and 1, the force from 2 and 1, which is K, okay, right? The force from the charge Q, 2 on Q1, right? Which is F21 KQ1 Q2 over D squared. Then you remember K is 9 times 10 to the 9, and you calculate the force. Then you keep going with arithmetic. The same thing with what? With the force 3 on 1. 3 on 1 here, K, KQ3 Q2 over 3 times 10 to negative 2 squared. Then we simplify. We found the two forces. Now here the idea yesterday I want to finish. Now we have the two forces which is one F, right? This guy, which is here, F31. I'm gonna write F31 here. F31, and this F2 on 1. This F2 on 1 and charge 1 is here. These two forces, they form a 90-degree angle. They form a 90-degree angle. They form a 90-degree angle. Let me find that. Where is it? Okay. Let's see. And then these two, the F21 and F31, they form a 90-degree angle. From basic of vectors, because force vectors, when we have a force, two forces, because both of them are vectors, then the resultant of these two forces will be this guy. You see this guy here, okay, which is pointing this way, and you can find it by using square root of F31 square, F2 square. Then let us find this guy and see how much my answer. Let me just find the answer for this guy. Okay, 180 square, 180 square plus 67.5 square, then get the square root for the answer. This 192. We end up with 192 Newton. 192.24 Newton. Now the teacher will ask you to find the direction. The fourth, look here, you have to imagine it. The charge here, the Q1 here, since she has two charges here and there, will directly move this way. What the direction? He wants the angle theta. How we find the angle theta? Look here. He wants this angle. Theta next to which one? Next to F31. Tan theta from basic of triangles. Opposite, which is this F21, this F21, this line. F21. This line is F21. F21 up. Opposite over adjacent. Opposite is F21 over F31, which is 67.5 over 180. The theta. Then theta equal what? Tan inverse of 67.5 over 180. Then we go to our calculator and we calculate what tan inverse of 67.5 divided by 180. Okay, and this give me tan inverse. Make sure that your calculator in the degree mode. Some kids in the test, they will keep it on radian mode, and that's give them the wrong answer. Then it's about the angle here, about 20.56 for this two decimal places, degrees. Okay, we're done with this. Let us keep going with our class. Now, the first thing we said, this chart, negative or positive, let me take negative because I start with positive, I'm going to take negative. Any chart has an electric field line. Okay. Also, any chart, as we discussed before, this wrong, right? I have to change my direction. Okay, I have to, because this small Why? Okay, I meant to do that because when it's negative, what's gonna happen, guys? When it's negative, the direction of the electric field line will be N. Now, as we said, this chart has electric field at any point in this area, and you will get affected if you come close to these points, close to the electric field of the chart. Also, we said this chart has electric potential, we call it voltage, right? Electric potential is a scalar quantity. At this point D, from the chart, there's electric potential V. You can calculate it KQ over what? D. How we calculate, if you remember, we said V equals E times what? D. Right? And this, we call this dot product. Dot what? Dot product. In math classes, I promise I will explain the difference between dot product and cross product. Dot product between two vector quantities give you a scalar quantity. Then V is a scalar quantity. Because of that, you have to take in your consideration the negative and the positive for the chart. The chart negative, the chart positive. You have to take this in your consideration. Then KQ over D at this point. Make believe somebody bringing another charge to this point D. But you don't know from where. From where you're gonna bring the charge? From where? From infinity. Usually we assume that these charges come somewhere here. If this is Q1, and somebody has a Q2, and somewhere here, and this is my infinity, and he wants to bring this to this point. It's not easy because there's a voltage. Imagine imagine you're sitting by, let me just make it simple and easy in your life. Sitting by yourself, relaxing, enjoying, reading, everything is okay with you, suddenly somebody coming close to you. But it's not easy to bring something. If we assume that the voltage at infinity equals 0, the voltage at infinity equals 0, and then at this point is what? Point A. Then you bring in something from infinity to A. Here we're going to define what? Delta V. Delta means change in V. Change in voltage. Change and voltage, which is V final minus V initial. V final. In my case, V final is V in my case. V final is VA, and V initial is V infinity, right? I start from here. This is my initial, and this is my final position for the chart. You bring it. V at infinity equals 0. Okay, good. The other question I'm going to ask you guys, and seriously answer this question. To bring a charge from infinity to this point is easier to bring it to where? Close. And you will accept it for the guy to be 5 feet away from you, 6 feet away from you, 7 feet. But when the guy comes in close, 3 feet, 2 feet, 1 feet, who are you? He needs a lot of work. To come close to you is not easy. It's not something simple. Then you are close. You're gonna be, the voltage is gonna be very high. The voltage is gonna be which is not easy to deal with. The voltage is gonna be very high. Why, guys? Just look. Because when D gets smaller, when D gets smaller, the value gets higher. D smaller, value higher. D smaller, value higher. Okay, then voltage, we know what the voltage, and we know what work, right? Because there's distance now. We know the work equal what? F D. And work is a scalar quantity. Work is not vector quantity, scalar quantity. There is no direction for work. There is no direction. Which is dot product F D cosine theta. And let us make believe theta equal what? 0. Theta equal what? 0, then cosine 0 equal 1. Now, okay. Let us see what's going on. Then work equal F, and F is Q E from before. F equal Q what? E, and we did what also? E equal what? E equal what? Come on, guys, still here? V over D. V equal ED, right? And ED equal what? Okay. Now he come here, back here, or equal what? F Q what? And V equal E times D. E D. We explain that scalar quantity. I don't want to say anything after me. Q, F, Q, E, and this D. And ED is what? V, but ED is what? ED is V. But we said there's what, guys? There is change in potential energy. The potential, potential, right? Not potential, potential, the electric potential, which is the voltage. There is change. Then W, and the work, electric work done to bring any object, any charge from infinity to there, Q, and ED is what? Delta what? V. Okay, that's delta V. If you want a Q, V, delta V, V, B, A minus V infinity. And V infinity is how much, guys? 0. We assume that the voltage at infinity equals 0, then QVA, QVA, QV, QVA. Now Q and VA, how much? V, if you remember the formula for V, K, Q at A over what? D. And then the work K, Q, right? Q, QA over D. Easy and simple. Thank you. Let us take a quick example. Let us make believe there's this example. Example. Q1, Q2, Q3, and this point A and B, how much work needed, this example, how much work needed or needed to move charge a charge move two microcoulomb charge, negative 2 microcoulomb charge from A to B. First, we have to find the potential at A, and look at it as like this. Work equal the work Q delta V Q VB from A to B, then VB minus VA. And no, I know what's a Q. A Q is how much the charge I'm gonna move is negative. I'm gonna leave it negative. Times 10 to the negative 6. And I need to find what VB and what VA and plug them. Let me calculate VB and VA. Let me calculate VB and VA. V at B, look here at this side. V at B comes from where? We have 2, now here, 4. Let me just use a different color for the distance. 4 centimeter, 3 centimeter, and we discussed this type of triangle, right? And we discussed this type of triangle. This has to be what? 5 centimeter, right? V at B, look guys, I'm gonna keep this problem to keep you for next time. But I'm gonna give you the idea to do it till I do it for you next time. V at B comes from Q2 and Q1, you add them. Then you're gonna K Q2 over 4 times 10 to the negative 2. And from Q1 is what? At B, we talk about B. The potential at where? At B, K Q2 at 4 times 10 to negative 2, right? Plus K Q1 over 5. The same thing at A from Q2 and Q3. You calculate it, you find the difference, and this is what I'm gonna do tomorrow for